Now let's do the environmental analysis, starting with the soil moisture regime. We've gone up to our site, we've taken measurements, and here's a summary of the physical characteristics of the site that we found. We're at 350 meters above sea level, 15% slope, 190 degrees aspect, so a south-facing slope. We're at a mid-slope position, and the shape of that slope is straight, so it isn't a concave or convex land surface, but a planar land surface. The parent material is colluvium. That's material that has arrived via erosion, and it's a well-drained soil. There's no glaying or major seeps. Glaying is what happens when the soil is saturated for a portion of the year, so iron or aluminum particles that might normally oxidize reduce instead in the absence of oxygen, so you get areas of the soil that have a very pale gray color. So we don't have that, and we also don't have major seeps. We haven't, in the soil pit that we dug, there isn't water seeping in from the edge. The humus is 5 centimeters thick, and the forest floor form is a motor, or specifically a moor motor. There's a 3 centimeter AH horizon under decaying wood. An AH horizon is the first mineral horizon, but one that has had humus mixed into it from above. And we also have a weak AE horizon. That's a zone of eluviation where fine soil particles have leached or eluviated out of that, so probably a thin gray line in the soil. The AH horizon and the BM horizon underneath it are both dark colored, and our soil texture is a silty loam with 50% coarse fragments. And when we dug our soil pit, we got down about 29 centimeters and then hit a restricted layer where we couldn't dig any deeper. We get out our field guide and we open it up to the key to relative soil moisture regimes. The actual key has a few more starting options. I've just pulled out a small segment of it for this example. So the first question is about slope position, and there's many potential options. I'm just showing 2 here. So if we're saying, are we at a middle slope or a lower slope or toe slope? And we already said we're at a mid-slope position. So did we see a water table or seepage or glaying in the soil? Nope. Is the slope greater than 35%? No, it was 15%. Is the soil particle size coarse? So this one might be confusing because you might think, okay, how do we define coarse? But fortunately, if you look back, there are some definitions about terms that are used in this key. And there's one there for particle size being coarse. So in our case, we have a silty loam with 50% coarse fragments. If we look at that definition, the first part is sandy with 35% coarse fragments, and this isn't a sandy soil. Or loamy, and we do have a loamy soil, but with 70% coarse fragments, and we only have 50%. So by this definition, our particle size is not coarse. Then is the soil depth less than 1 meter? Yes, it's 29 centimeters, and then we hit a restricted layer. And that definition defines it as I mentioned it a minute ago. So that leads us to a relative soil moisture regime of 3 or submesic, with the possibility of being as low as 2 or as high as 4, so subxeric, 2 mesic.